So if you can see this. Walaikum assalam wa rahmatullah. Jeet, how are you?
Sir, can you send the recording of this meeting to MS Teams?
Sorry?
Would you send the
You want me to share the recording?
meeting to MS Teams? Yes, to MS Teams for 9.
Yeah, no problem. I'll share the recording.
Thank you.
Okay, so what I want from you people is that your mics should be muted. Okay. And if you have any questions, you can ask me. When we are finished with the topic, you can ask me. So the topic for today, which is selected by your friends, it is energetics. Okay. So what is there in the energetic that you people are going to study, and what is the questions which the examiner is going to ask you about? Okay. So let me go straight forward to the page here. This is a page from your book, the exercise page. Okay. You must be familiar with these sort of data. These are called the bond.
Yes, sir.
Okay. These are called the bond energies. So I'll be using my screen. There's a white page, blank page with me. So I'm going to use this page. First of all, let me just make it very. Okay. So what are we going to study in this chapter? We are going to study, first of all, the definition. And you need to be knowing about exothermic reactions. Okay. And you need to be knowing about endothermic reactions. Okay. This is the first thing. So definitions should be clear to you. And I need to tell you one thing, that whatever I'm teaching you here, it is from the past papers of Edexcel from 2000 till 2023, 2022 past papers which are there, and the questions which are already repeated in the exams. So first of all, what is exothermic reaction? The definition is very simple. It says that those reactions in which heat energy is released to the surrounding. Okay, so you will get either 2 marks for it or 1 mark for it. Those reactions in which heat energy is released to the surrounding. So we will have system, and you're burning something, and you have surroundings. So from system to the surrounding, it's exothermic. So delta H value will be negative for it. Now, what is delta H here? Delta H is the enthalpy change or heat change during a chemical reaction. Are you getting my point?
Yes, sir.
Okay.
Yes, sir.
So if it is the endothermic reaction, the heat energy will be flowing from the surrounding to the system. So delta H will always be a positive value. And what is delta H? Once again, let me repeat it. It's the heat change during a chemical reaction. We call it as an enthalpy change. Enthalpy change. Enthalpy change. Okay. Now, how do we calculate it? This is the second part. And before that, you need to know about the unit. If you know the unit of the enthalpy change, then the calculation process is very simple. So the unit is kilojoules per mole. Yani we have 3 things in this calculation. One is the kilo, the other is the joule, and the other is mole, per mole. So whatever you're doing is you're doing the calculation with kilojoules per mole. There are some people who are still waiting or what? Admit all. Okay. So it's kilojoules per mole. That's the enthalpy change calculation. So whenever you see delta H, you will see that it's always calculated in kilojoules per mole. Let me add some more. Okay. It's kilojoules per mole. Once again, let me repeat, you got 2 definitions now. Every definition is of 2 marks. Exothermic reactions, those reactions in which heat energy is released to the surrounding. An endothermic reaction in which heat energy is absorbed by the system. When we say that the heat energy is released, it will always be a negative value. When we say that the heat energy is absorbed, it will always be a positive value. Are we clear till these 2 points?
Yes, sir.
Yes, sir.
Yes, sir.
So we need now 2 things in the calculation for us. One is the joules calculation, which you will be converting into kilojoules, and the other is the mole calculation. Okay, so straightforward, I'll go into the 2 energy profiles, which are also very important. One energy profile is for the exothermic reaction, and the other energy profile is for the endothermic reaction. So you must be looking at these energy profile as well. These are the diagrams actually, which you will be seeing in this way. Okay, there is an energy profile like this, reactants, and you got products. This is for exothermic reactions.
Sir, Shakir made us do this. We have this in our copies.
Huh?
Sir, we have these both the exothermic and endothermic diagram in our copies.
See this now. We have a delta H value here. This is delta H, and this value is negative always. And then we have the exothermic one with us and the endothermic one with us. Let me draw with a different color this one. The reactants are lower than the products. These are the reactants and these are the products. Now by reactant and product, it's a general one, right? So you will be given an equation like, for example, CH4 combustion is given there plus oxygen. It will give you carbon dioxide plus water. Okay, this delta H is negative. Okay, so you will apply the reactants here, which is CH4 and oxygen, and the products you will apply here, which is carbon dioxide and water. So sometimes they're asking you that label the diagram with the reactants and products. So you're not supposed to write simply R and P or reactant and product. You're just going to label it with the exact reactants and the exact products. Okay. Any question till this point?
No, sir, it's okay.
Okay. For the
Can you tell again? Can you tell again?
For the reactants and products here in the endothermic one, you will be having like calcium carbonate. Thermal decomposition is happening. Calcium carbonate. It's an endothermic process. This is the delta H for it. Please mute your mic. And it's a positive value. It will give you carbon dioxide plus calcium oxide. So this reaction is endothermic in nature, and delta H is a positive value for it. So positive value P, you will get a positive value here. Now these energy profiles are very important. You can get 3 marks out of it. 1 mark is for the reactant. Please mute your mic. 1 mark is for the reactant, the other is for the product, and the other one is for the delta H line, which you're going to show it. Okay, so that's something very, very important which you need to be knowing. Okay, then after this, after knowing these 2 energy profiles, now let us move towards 2 types of calculations which are very important in your course. The first calculation is basically you will be provided this sort of information. See, the bond enthalpies are given to you. Now, what is a bond enthalpy? Bond enthalpy is the energy which is needed to break a bond or to make a bond. So bond energy can be either exothermic or can be endothermic, and it can be either positive or negative. If you're breaking a bond, it will always be a positive value. If you're making a bond, it will always be
Negative.
Negative.
right? So bond breaking, keep always in your mind, bond breaking is always positive and bond formation is always negative. In other words, this one is endo and the lower one is exo, right? Are we
Yes.
clear with this part?
Yes,
Now,
sir.
Yes,
Yes,
sir.
sir.
I'm just picking one of this equation now. We have CH4, the reactant side, and we have the product side. Now, what is happening on the reactant side? On the reactant side, there's always a bond breaking, okay? And on the product side, there's always a bond formation. Are you with me, everyone?
Yes, sir.
So I'm going
Yeah,
to
got it.
Yeah, okay, I'm picking this equation now and I'm going to solve it here. The important thing is that you need to know about the expanded formula, right? Or the displayed formula, which is this time in grade 9, we'll be giving you the displayed formula, but in grade 10, you must be able to draw the displayed formula. So I'm going to pick up CH4 with Br2. So let me write first of all. CH4 is there with Br2 and the result is CH3Br plus HBr. That's the result. Okay. Now I'm going to write the expanded form of this formula. So of this equation, first of all, we have carbon in the middle, 1 hydrogen, 2 hydrogen, 3rd hydrogen, and 4th hydrogen. This is CH4.
So will we have to make this?
I'm telling you in grade 9, we'll be providing you this. But in grade 10, you will be familiar with this time. Okay, because you'll be going into organic chemistry where we'll be teaching you this formula. So right now at this moment, they will provide you in the question paper.
Okay, sir.
Right? Okay, now the other expanded version is Br with another Br. Right? It's Br2. And what do we have on the other side? We have C with H and H. All the 3 hydrogens are there. And there's one Br connected. Okay. And then we have an HBr plus H with a Br. Okay. Now, we need to see basically, this is the reactant side and this is the product side. Keep in mind the arrow is there in the middle, right? Now, when you see this sort of an equation, the reactant side is always positive with values and the product side is always negative with values. Are we clear with this?
Yes, sir.
It's always
sir.
positive and the product side is always
Negative.
Keep that in your mind. By positive means that whichever value is given to you and you're putting that value on the reactant side, it will have a positive sign with it. And whichever value is given to you in the product side, it will have, see this now, the values are having no signs on it, right? It's 944, but we don't know whether it's a bond formation or a bond breaking. So it depends on which side you're getting it. Now, we have how many CH we are going to count it. How many CH are there? I'm just clicking on every CH. So I want you to please focus here. 1, 2, 3, and 4. How many CH do you see?
4. 4 times 413.
4 times CH relations are given there.
Yes.
Right? Plus, how many BR relation? I'm counting the central line, the bond, okay? So how many BR relations are there? It's 1 time.
1.
So just write 1 time BR relation. Okay.
So where did you get this question from? Like what chapter, what page?
This is Hassan Qasim, please change this. This class is being recorded.
Sir, where did you get these where did you get this question from?
This question is from your book. And if you open your book, it's on page number 225. So these are relevant questions to your course. Okay, now on the other side, how many CH relation do you see? 1, 2, 3. So we got 3 times CH relation on this side. And 1 is a CBr relation also. So 1 time we have C with BR relation here. And I'm going to add these values, keep in mind. And 1 time I'm having an HBr relation. So 1 time H and BR relation is there. Now I've identified that I have 4 CH relation here and I have 3 CH relation here. Now you can do 2 things here. 4 CH relation on this side and 3 CH relation on this side. So 3 CH relations are common on both the sides. You can cut them. No need of using 3 times and 4 times. Just simply you're having 1 CH relation extra on the reactant side. Right? So I'm going to pick the values now from the table. And the values are CH relation is how much? It is
413.
413. So I'm going to take 413. Okay. This is 413, but I'm taking it one time because 4 and 3. So the 3 and 3 on both sides are cancelled out. So one time 413 plus. How much is the BR relation? If you open your book, you will see BR relation is BR.
193.
It's 193. Keep in mind, this is a positive value. Okay. So we are going to add this value and we'll get a result. I want somebody to add this value for me. 413 plus 193.
Sir, 600.
606.
Yes.
606 kilojoules per mole. Keep in mind that's the unit. And on the other side, the CH is gone now because 3 CH are cancelled with the other one. Now we are left with an HBr relation and with a CBr relation. So we are going to pick these two values. One HBr, this is the HBr 366. So I'm going to take 366 plus the CBr relation. I'll
Sir,
pick
will be the table given in exam?
Absolutely, it will be given in the exam. So no
In
need to
board
worry.
exams also?
In the board exam and in the school exam, in both. If the table is not given to you, you can't do this question.
So where's the CH3 cancelled?
CH3,
To CH4.
where is
Sir,
the
where is
CH3
it
gone?
cancelled?
See, on this side we are having 4 CH. And on the other side we are having 3 CH. So 3 CH and 3 CH are gone because it's balanced. The equation is balanced.
4 minus 3, so you get 1.
So you are left with 1 CH on the reactant side. On the other side, nothing is left now.
Okay, sir.
Okay. Now we are left with the CBr relation. The CBr relation is how much? 290.
Yeah. So 656.
290 and the total is how much? How much is the total, please?
656.
656. Okay, keep that in mind. This value is negative. So now you got the value of the reactants, 1 mark, and you got the value of the products, 2 marks, right? Now the third mark is overall for the reaction. So we are going to add these two values now. You got a negative value.
The product is negative, right?
Yes, the product is always
656.
negative. So if you're using this method, the way I'm telling you, you're not going to use any formula like reactant minus product or product minus reactant. Leave that. Don't use that. Just keep in mind, reactants are always positive. Products are always negative. Now you pick up the negative and the positive values and add them together. And how will you add now? 606, a positive value, minus 656.
Will you do measuring in enthalpy changes?
Sorry?
Sir, will you do measuring enthalpy changes?
I don't understand what you're asking.
Sir, will you do measurement of enthalpy changes?
This is the
Sir,
enthalpy change.
Sir, the answer is minus 50.
Sir, measuring them, sir.
I'm not getting you.
Razmi, this is what he's doing.
This is what the
Sir,
question.
ignore him.
Okay, 606 is a plus value and minus 656 is the other value with you. Now add these two values together, a plus value plus a negative value. You will get
Sir, minus 50.
minus 50, but the unit, what is the unit? Kilojoules.
Kilojoule per mole.
Kilojoules.
The overall reaction is exothermic. Are you getting my point?
Yes, sir.
The overall reaction is exothermic. Now, I want everyone to look into this equation now. Okay, I'll be writing the expanded version now of this equation. The equation is hydrogen is combining with chlorine, making hydrogen chloride gaseous state. So now let me remove this. If you have any question, you can ask me, but let me finish the second question. If you still have a doubt, you can ask me.
So we can even use the formula breaking and making bonds, right? Minus.
Of course. See, the formula is designed from what I'm telling you.
Okay,
But
okay.
you know, sometimes we forget the formula. We don't remember the formula. So it's easy to remember the equation, to look into the equation, and you see that reactants are making the products. The energy involved here is positive. The energy involved here is negative. Okay. Then add those two values and get the result. It's very simple.
So what is RP?
Reactants and products.
Oh, okay. Yeah.
So in product side, when we multiply, we always find it in minus and then we plus with.
Absolutely. Okay, now I'm going to the second equation. The second equation
Sir, I
is
got the answer to the second equation.
just wait, just hold on. We'll be comparing the answers then. We are having chlorine combining with hydrogen is making 2 times HCl. Okay, now chlorine versus chlorine, hold on. Cl and Cl, one relation is there, and H and H, a single relation is there. So you will put the value here, put the value here, you will add these values together. This is your reactant side. And then 2 times you will have an H and a Cl value. Okay, I want everyone to put the values. I'm putting the values for you. So first of all, H and H relation is 436. Okay, so I'm going to take.
Sir, plus 243.
And the other one is ClCl.
ClCl is 243.
243. So it's 243. That's the other one. I'm going to add these values together. I'll get an answer and I'll pick 2 times the HCl value, and the HCl value which is given to me is 432. So 432 is the HCl value, right? Now multiply with 2.
So adding this, it's 679.
4,
The left hand side.
8. Right? And this one is
All right. 679.
Okay, this is a positive value and this is a negative value. Add these values together and get the answer. It's definitely a negative answer.
Sir, it's minus 185.
Minus 185.
Minus 185. Don't forget
Exactly.
kilojoules per mole.
Sir, it's exothermic.
The reaction is exothermic. Absolutely. There will be another question they'll be asking you. Is the reaction exothermic or endothermic? So the reaction is exothermic.
Sir, till what time is the meeting?
Sorry?
Sir, till what time is the meeting?
See, this is not the upgraded version with me. So 40 minutes after like 140, it will be wind up, but I'll be connecting it till 2, right? Because I've given you 1 hour for it. So I'll be re-inviting you for another one, okay? And you can join me for another one also, or maybe the same one, or maybe we'll finish with 140 because we've, okay. So is this fine now? If you have any question, you can ask.
Yes.
Sir, very easy. Very easy.
Okay. Now let us move towards the complicated version, which is the enthalpy of combustion. So I want everyone to listen to me very carefully because I will be doing here on this screen the enthalpy of combustion calculation. And I want everyone to listen to it very carefully. This is very important. These enthalpies are important till grade 12. If you're studying chemistry, you have to be studying these things again and again. So keep that in your mind. Enthalpy of combustion is my next topic, okay? Enthalpy of combustion.
Sir, what do we mean by combustion?
Combustion means burning something in the presence of oxygen. When you burn something in the presence of oxygen, it is called combustion. There are 2 types of combustion. The complete combustion, where a plentiful supply of oxygen is needed, and it will result in making carbon dioxide and water. And there is an incomplete combustion where a limited supply of oxygen is required, which is resulting in carbon monoxide and water. Carbon monoxide is poisonous in nature. So if it is mixed with your lungs, it will be combining with your blood, making carboxyhemoglobin, which is incapable of taking oxygen to your lungs and to your body. So that's why suffocation will happen and people die because of this. Okay, now I'm going to work on the combustion enthalpy, but this is experimental one. Let's suppose that we got ethanol with us, ethanol, and the formula for ethanol is C2H5OH. We call it simply alcohol. What is the MR of this? You might be familiar with calculation of MR. We got 2 carbons in it, so 2 times 12. Plus we got 6 hydrogens in it, so 1 times 6. And we got 1 oxygen in it, so 1
So
times
why
16.
2 times 12?
Because 12 is the relative atomic mass of carbon, and carbon is 2 times. So everything, the 12, the 6, and the 1 and the 16, I'm picking it from the periodic table, the relative atomic masses. So the relative molecular mass is, if you add all these values together, you get 24 plus 6 plus 16.
36.
Is it 36 or is it 46?
Sir, 46.
Okay, so it's 46. And what's the unit for it? These are 46 grams per mole. This is the MR of ethanol.
Sir, won't you multiply H by 5 because it's H5?
My dear, there's 5 and there's with the OH also. You can see another H also. There are 6 hydrogens. So you should be very good in looking into the formula. There are 5 hydrogens with C2H5 and there's OH. So the total hydrogens are 6 in number. So the relative molecular mass is 46 for ethanol. Now, keep in mind, what are we doing? We are calculating the enthalpy of combustion. So I'm taking some ethanol in the spirit lamp. This is the spirit lamp, which I'm going to use for burning process. And what is there in it? I'm taking the C2H5OH in this spirit lamp. So what is the mass which I'm taking initially? All the information will be given in the question. Keep in mind, all the information which I'm discussing right now will be given in the question itself. So now I'm working on ethanol. Mass of C2H5OH before burning. Okay, how much is that? I'm just supposing it that the mass which is given in the question is, let's suppose 100 grams. You will burn ethanol, and when you burn ethanol, you will keep some water in the beaker. The heat will be taken by the water, and you will measure with the help of thermometer. This is thermometer. Okay, you will see the temperature change also. So mass of the ethanol which you have burned, which was there before burning, is 100, and after burning, let's suppose 65 grams is left after burning. Now, how much did you burn?
Subtract.
35.
So the burned one is 35 grams. How many moles have you burned?
0.3.
35
So
over.
you will take 35 and you will divide it by the relative molecular mass of ethanol, which is 46. So what is your answer for it?
Sir, but some of releasing
0.76.
0.76
0.76.
moles of ethanol you have burned. Keep that in mind. Now this 0.76 of ethanol is converted into heat energy, and that heat energy is taken by water. Okay, so now I'm going to change the color and I'm giving you the information about water now. So mass of water, how much water did you take? I'm just assuming that you have taken 120 grams of water, right? This is the mass of water which you have taken in the beaker. Okay, what was the initial temperature, yani T1, when you started heating it? Let's suppose it was 25 degrees Celsius. And how much was the heat raised up? Let's suppose 75 degrees Celsius. It was risen to 75 degrees Celsius. So how much is delta T here? Change 75 minus 25.
Sir, 50.
So 50 degrees of Celsius heat is raised up, right? Now, Water has a specific heat capacity, which means
Four
that
4.18, sir. 4.18.
4.18. So the C value, which is, I'm going to change the color for it now. C is how much? 4.18.
4.18 or 4.2.
Absolutely right. Now, I'm going to calculate the heat change now. Okay, which is Q.
Sir, Q
M
equals
C
mass multiplied by
delta
C.
T, where M is the mass of water, which is 120. C is the specific heat capacity, 1.8, 4.18, and temperature is 50 degrees of Celsius. Everyone is there with me?
Sir, but some of the
Yes, sir.
heat is released in the air.
So give me the answer for this, please.
Sir, it's 25.08
Sir,
kilojoules when we divide by
25.08.
Why 25 point? 120 times 50 times 4.18. Do it again.
Sir, we actually divide by 1000.
You should not divide unless I tell you to do it.
Okay, sir.
Sir,
It's
25,080.
25,080.
25,000, huh?
Yes, sir.
Yes.
Just only 25,000?
No, sir,
25,080.
80.
25,080.
Yes, sir.
Okay, this value is in joules. So you get 1 mark for calculating this value in joules. But the demand is in kilojoules, so that's why you are going to divide by 1,000. So you will get an answer of 25.08 kilojoules. Now, what is left in the answer? Per mole is
So we have
left
to
in the
write
answer.
in both units. So we have to write in both units.
25.08, but per mole is still left. So the next
Sir,
part
we'll
is,
divide this by 0.76.
yes. So I'm going to pick another color and we'll see this. So delta H is equal to Q divided by the number of moles. Q is equal to 25.08 divided by 0.76. And you will get the final answer. And what is the final answer?
Sir, 33.
33, just only.
So we'll write in both joules and kilojoules.
Sir,
This is-
kilojoule per mole.
This is in kJ per mole now.
Yes, sir.
Are we clear with this?
Yes, sir.
Yes, sir.
If you have any question, you can ask me now. You got 4 minutes
Sir?
for this first session to end up. So you can ask me if you have any question.
Sir?
Yes, my dear.
So we'll write both in joules and kilojoules in the exam.
See, step number 1 is to find out the joules. And then divide it, like you need to have the reason for it. Why you're dividing by 1,000? Because you're finding it in kilojoules. The demand is in kilojoules. The unit is in kilojoules per mole, not in joules per mole. And it's not joule, it's joule.
Okay. So we have to write in both.
Not writing both. The final answer should be in kilojoules per mole. You see the final answer, what did I write? 33 kilojoules per mole. That's the final answer. But these are the steps. Every step is giving you marks. This is the first step where you get 1 mark. When you divide by 1,000, you get another mark. When you do this calculation, divide by the number of moles, you get another mark. And before that, if you're doing this delta T calculation, 1 mark is there for it. If you're finding the
Sir.
number of moles, 1 mark is there for it.
Sir, Shakir said that this question in total will be for 10 marks, approximately 10 marks.
Along with the, this question is only for 5 marks. Okay. First mark is that you are calculating the number of moles. Second mark, you are calculating delta T. Third mark, you are calculating joules. Fourth mark, you are calculating kilojoules. And fifth mark, you are calculating kilojoules per mole. Okay. But along with the definition, exothermic, endothermic, enthalpy of combustion, yani 2 marks for exothermic definition, 2 marks for endothermic definition, 1 mark for the conversion process. So you got 5 plus 5, 10 marks then for it. Any other question? Yes, please. I'm just waiting for you people. If you have any question, you're most welcome to ask. Okay, do you have another topic to continue with, or that's fine for today?
That's
Sir,
easy.
enthalpy of neutralization.
Enthalpy of neutralization?
Yes, sir.
Yes, sir.
Okay, so let me start with the enthalpy of neutralization. We are just left in this session with just, 1.5 minutes, but let me start that. So enthalpy
Sir,
of sorry?
sir, where will you send the link? I'm not sure of it.
I will be sending the link immediately in the WhatsApp group. Okay.
Okay,
So,
okay.
yeah, and just give me a minute so that I can remove this. Okay. Okay, what is neutralization basically? Neutralization means when you react an
Acid
acid
and
with an alkali, that reaction is called neutralization. Okay. In this reaction, the hydrogen part of the acid is reacting with the hydroxide part of the acid, making 1 mole of water. Okay, so whatever we are doing, the calculation will be for 1 mole of water actually. Keep that in your mind. Now, in some of the reaction, like when hydrochloric acid is reacting with sodium hydroxide, it's a monoprotic acid, means 1 hydrogen is there in it, and sodium hydroxide is a monobasic acid. So the reaction which is going to take place between HCl plus sodium hydroxide is releasing NaCl